All right. Okay, so we should be right on page 7, guys, where it says find the z-score using the table. So on the previous time we did the table, it was find the area from the z-score, and now you're doing just the reverse. You're finding the z-score from the area. Okay? All right, so your tables always give you the area that's to the left. Okay, so what I'm going to do is I'm going to look for this number in the body of my table. Okay, so I want to find the closest value to that. So 9131, well, I found it exactly. So my z-score is 1.3 and then 6. So that's pretty straightforward. So for 12 now, it's given to you as a percent, so you got to change it. So on this one, I want to find the entry closest to 0.83. Because this is a percent, so I move it 2 decimals over. Okay, so we go up here and we try to find the closest one to that. So 83, here's 8315, 8340. So 8315 would be my closest. Okay, this guy right here. Let's use yellow. Okay, so that's going to be 0.96. Yeah. Let's see, maybe I missed it. 8289. Yes, you're right. Thanks. That's my mistake. So this is the closest. 8289 is closer than 8315. So, yep. So it's 0.95. Okay. So this was number 11. This was number 12. Okay, and now the last one says find the z-score for the shaded area. Okay, so this part would have to be 80% if the unshaded part was 20%. just look that up. Closest to 8. Closest. So I got 823, 8023, and I got 7995, which is closer. So 0.84. All right, so you got in 2019, more than 1.6 million students took the SAT. Distribution of scores on the math section out of 800 is approximately normal with a mean of 528. So our 528 is going to go here. And then we put that right in the middle. Okay, and then the standard deviation is 117. So each one of those marks, I add 117 to 528 and I subtract it to get both sides of the, to fill out my table here, or to fill out my curve. Okay, so I'll do that. Okay, so the question's asking you what proportion of students who took the SAT scored less than 350. So if I was to estimate where 350 is, it'd be between these two. It'd be between -1 and -2 standard deviations, somewhere in there. So I'm just going to kind of estimate 350, right? And so what it's asking me for is what's the area, what's the shaded part? So this is what we called a type 1 problem, where you were given a value, you scored 350, and you want to find the area. Finding the area is the same as finding the proportion. Okay. All right, so it tells you exactly what to do. Convert it to a z-score and then look it up on the table. All right, so we're going to convert it over here. So this is going to be 350, that's my value. Okay, and then I'm taking away the mean, which was 528, and I'm dividing by the standard deviation. So I do that on my calculator. Take away 528 divided by 117. Okay, and you go out to two places, so 1, 5, 2, 1, that would go to just 5, 2. So negative 1.52 is my z-score. So this one, I think you got to use your full table. Okay, so we go to that. We know that this is going to be a negative, so we look for the negative side. 152. Negative 1, 5, right here. Then go over to 2. So there's my percentage right there. I just got to change it into a percent from that decimal. So 0.643. 0.643. Okay, so I get 0.643 That's going to become 6.43%. That's the proportion. Okay, now number 15, I changed up a little bit. So once you have this one done, this part is going to change to our greater than 120, which is really fast. Think about a fastball in baseball is like 100. This is going 120. Let's see, greater than 120. Okay, all right. Let's see, his average speed is 112. Standard deviation's 5. So 112, 117, 122, 127, 107, 102, 97. Okay, so greater than 120. So if I was going to put that on here, 120 maybe would be about there. So I want to find the area that is to the right of that. All right, so remember, to get that, you got to subtract 1. You got to take whatever you get from your table and subtract it from 1, because it's to the right. Okay, so we're going to convert it and then find the number and subtract it from 1. All right, so we got 120 divided by 5. Okay, so we find that on our table, 1.6. Now this is a positive because it's to the right of the average. So 1.6. Okay, so that's right there. So 94.52. Okay, so I'm going to go 1 minus 0.9452. And I would get this. So 5.48% is my answer. Okay, so both of these were type 1. This was a type 1 problem. And 14 was a type 1 problem. And now 16 and 17. Let's see, this is 14, 15. This should be 16, 17. Yeah, okay. All righty, these are going to be type 2. All right, so the problems are the same, okay, except you're just finding out you're finding a different question. Okay, so this isn't changed. It's the same as the one on the front. So now this one's telling you find the math score located at the 39th percentile. All right, so when we look at our charts, guys, the 39th percentile, if I was going to shade in 39%, so it kind of gives you an idea of where it would be, okay? If you shaded all the way up to the middle, that would be the 50th percentile. If you shaded up from the left up to the first one, that would be the 16th percentile. So the 39th percentile is somewhere between these two. Okay. All right. So I'm just going to kind of estimate. I'm going to say it's be about here. And then it's telling you that this shaded part is 39% or 0.3900. Okay, so this is less than 50, so I know I'm going to it's going to have a negative z-score. So I'm going to find that entry. Okay, so I'm looking at this negative table 39. Okay, so 0.36. Let's see, this looks like it's the closest. 3897 would be the closest to 39. So negative 0.28. So that's my z-score. Okay, so I just did I just converted it to a z-score right there. I did that. And now I'm going to plug into this formula and solve it for the letter x. Right, so let's go. Perfect timing. Let's go. Bring the action. Okay. So this was negative 0.28. This is x. Okay, now you got to solve that for x. So 1. All right. So this is negative 3276. and then add 528, and there's your answer. Okay, so let's see. 32, 79, 76. Plus 528. Okay, 495.24. So roughly a 495 at Math SAT falls at the 39th percentile. All right, so it's the same problem as this, the second one on the previous page, except now you want to find the speed that goes with the 85th percentile. So this again is a type 2. All right, so let's see, we got 1, 1, 2, and then 1, 1, 2, this is 5, 7, 27. Minus 5, minus 5, minus 5. Okay, 85th percentile. So to give you an idea of where this is the 50th percentile. Okay, and the 85th percentile, if we look back at this chart here, it's going to be just a little bit past. I'm going to shade everything up to that standard deviation because that's 84%. So we're going to shade just a little bit. We're going to draw our line a little bit to the right, and then we're going to shade. Let's see. So it's going to be just a little bit to the right of this first standard deviation. Okay, and now we want to find the area right here. Okay, so we find that on our table. We know it's going to be positive because that's more than 50. So I'm going to find the entry closest to that. Okay, so let's see. 8500. Okay, there's 8508, 8531, 8485. So that's your closest. $1.04. And now you just plug it in and do the math. So let's see, 1.04 equals X. It's 1, 1, 2, 5. And this is what you end up with. X is 117.2 miles per hour.